This is what they call a proof for evolution. Peppered moths. The story that students are told routinely is this. Prior to the industrial age, there was 95% of the light-colored moths that you can't see. 5% of the dark because the birds could spot them on the trees. They would eat them off. And then we had the industrial age, Europe. Coal burning, lots of ash, landed on the trees. The trees were now covered with this soot. And the population shifted. Now we got 95% dark, 5% light. And they call this evolution in action. And folks, listen to me. It's in basically every single textbook in my office. This is one of those support for evolution. It's in the British Museum of Natural History. The only problem is those moths, they don't rest on tree trunks. You say, wait a second, Brett, back up. Hold on, you just showed us pictures. Yeah, those are dead. They've either been pinned or glued to the tree. In 40 years of research, folks, they only found a handful actually resting on tree trunks. Number two, they don't have a tendency to choose matching backgrounds. They don't look and say, oh, that's a dark tree, I'll land there. Number three, though, most importantly, the guy who did the original research, his name was Kettlewell. Nobody has been able to replicate his findings. You know what we call that in science? Garbage. And yet, we keep putting these fake staged pictures in the textbooks. We ask a textbook writer, a guy named Bob Ritter, we say, hey, why do you keep using these? Students, I want you to look at what he said. Because to me, this is pretty telling. He said, you have to look at the audience. How convoluted do you want to make it for a first-time learner? The advantage of this example of natural selection is that it's extremely visual. We want to get across the idea of selective adaptation. Later on, they, talking about high school students, can look at the work critically. Later on, you can discern if it's true or not, but it sells the picture we want it to sell.
It's time to debunk the debunking of Kettlewell's peppered moths. Let's start with the very, very brief history. The peppered moth, common in England, exists in two distinctive forms, the typica, a grayish pepper color, and the carbonaria form, which is black. The difference between the two forms is a single well-known mutation in a single gene. It is a population geneticist's dream because it has an obvious, scorable phenotype, and the underlying polymorphism is a simple Mendelian single nucleotide change. There are so few simple examples like this in real genetic case studies. It had been observed by entomologists that the carbonaria form, which prior to industrialization and the accompanying pollution had been extremely rare, less than 1 in 100 pepper moths, were now outnumbering the typica, but that this pattern reflected the amount of coal being burned in the local environment. On the outlying islands and rural areas, the typica still dominated. Kettlewell was a British medical doctor, geneticist and entomologist, and found the issue of the peppered moth interesting. He spent many hours observing the behavior of these moths, and he noticed that the different forms had very different visibilities on trees where lichens were abundant versus trees where pollution had darkened or killed those same lichens. First, he made careful observation of his own ability to detect the live moths in daylight and low-light conditions. He advanced a scientific hypothesis that bird predation created a differential fitness advantage for melanism, or the different colored forms, and he set out to falsify it. He created an experiment where dead moths of each type were placed side by side on a tree trunk to see which ones the natural predators of these moths could identify most easily. He also created experiments in controlled cages where a particular bird was released along with the two forms to judge if there was variation in color preference among the individual birds. And he did a wild experiment where an equal number of each form were released into polluted and unpolluted woods, and then the survivors were tallied the next day. There was a consistent finding that melanism produced an advantage in survival from predation by keen-eyed birds. So now we come to the fraud, or rather the urban legend of fraud. In fact, the experimental designs used by Kettlewell were considered by many entomologists as too artificial, and some of his assumptions were troubling. But at no time was he criticized for putting dead moths on trees by other scientists. That's simply how you can make sure that the moths are equally available to each bird for that one experiment. It's an experimental control, no different than testing a drug and a placebo on equal populations, or blinding investigators or participants to which arm of a drug trial they're in. These moths do rest on trees. It's just hard for a scientist to get reliable data with living moths if they have to wait for an equal number of each form to happen on the same tree at the same time with a bird watching and willing to attack while a lab coat wearing scientist watches from the bushes. The next point Dr. Harrub makes is that no one has ever been able to replicate Kettlewell's results. That's easy to prove false. A scientist by the name of Michael Majerus repeated the experiments very recently, though he died prior to the final publication, and his collaborators published his results posthumously. The results, using careful controls and better experimental design, more or less agreed with Kettlewell's results, plus or minus normal variation. Majerus found that the Typica had between 10 and 20% increase in fitness in unpolluted woods. This experimental data can be added to field observations, which noted that after clean air legislation had an effect in England, and the woods were no longer polluted, the Typica returned to their pre-industrial relative abundance. The same phenomena, the return of a lighter colored form, was observed in the northeastern U.S. on a subspecies of the peppered moth found there, following the reduction in air pollution during the 1970s and 1980s. So the peppered moth, far from being built on falsehoods and misunderstandings, is actually very well supported. Dr. Harrub's version of it, however, is riddled with misunderstanding, urban legend, and poor research. I would suggest he do a bit more background research before repeating these falsehoods again. Thanks for watching.